Today we're going to talk about calculating second differences in a table. We've already talked about finding first differences in a table, so this is just a little bit of an expansion of that. When we find first differences in our previous sections, the first differences were all the same. And I'm going to remind you by pulling this table in here, what I'm looking at when I say they're all the same is the change in y values increased by the same amount. This was all plus 5, this was all plus 8. So they were all the same. So there was just a first difference because none of those were different. And this turned out to be the slope. When the first differences are the same for the entire table, it is a linear table. It represents linear equations. That's the y equals mx plus b, if you are comfortable with the slope-intercept form. So it is the change in y over the change in x. But when the first differences in a table are not all the same, we have to identify a second difference. Second difference. And you're going to be doing this exactly like you did when you found the first difference. You're just going to move out a little bit, and you're going to look for a change in those y values. If the first differences are not the same, but the second differences are the same, then it is not a linear equation anymore. Now it's a quadratic equation. So let's review what a first difference looks like. Okay, a first difference is where the changes between the y values are the same right away. Like 1 plus 2 is 3, and 3 plus 2 is 5. So my first difference is just 2. Okay, it's just 2. I don't have to worry about anything else because it's just 2. However, if I need to find my second difference, I have to look at things a little bit differently. So let's look at this. To go from 1 to 3 is plus 2, and to go from 3 to 7 is plus 4, and to go from 7 to 13 is plus 6. So my first differences, these are my first differences, they are not the same. So I have to go out a second level. So I've got these little arrows here going out this first level. Now I'm going out this second level. The difference from 2 to 4 is plus 2, and the difference from 4 to 6 is plus 2. So guess what? I've already established now my second difference. So my second difference is 2. Second difference is 2. All right, so in example 2 over here, let's see what's happening here to see if this is going to be a quadratic equation or a linear one. This is negative 4, and it's going to negative 2. Well, that's plus 2. And negative 2 to 0 is plus 2. And 0 to 2 is plus 2. So this is a first difference. So this means this is linear. So it's not going to have a second difference. But let's look at example 3. So we're going from 19 to 24, and that's plus 5. And if I'm going from 24 to 31, that's plus 7. I'm doing a little bit of mental math here, but if you don't know what the difference is, you can always start with a higher number and subtract the next one that's right above it, like 31 minus 24 is 7, okay? So let's look at this. From 31 to 40, this is plus 9. So my first differences are not the same, okay? So I have to keep going and looking for something that is the same so that I can stop, and that way I can identify what type of table it is. Well, from 5 to 7 is plus 2. Then from 7 to 9 is plus 2. So here are my second differences. Let me go ahead and write this a little more clearly so you can see it. Second differences. Okay, so this means this is a quadratic table. Okay, this is a quadratic table. Give this a try on the Do It for calculating second differences in a table. And if you do well on that, then go right ahead and feel free to prove it. Thanks.